Guys, today we're taking a look at developing some area formulas for some pretty common two-dimensional polygons. We're going to start off with the area formula for a rectangle, which is really familiar to you guys already. It's simply the product of the base times the height, or the product of its dimensions. So our first example says to find the area of the rectangle whose dimensions are 6 by 12 inches. We're simply going to take 6 multiplied by 12 and get our 72. Now, since we're talking about area, and area is a measurement of the number of square units contained within a polygon, then our unit should be inches squared. Our next example is that of a triangle. Now, for a triangle, we need to know the height of that triangle, which is that perpendicular distance to the base from one of its vertices. So we're going to take the product of the base times the height and divide that in half. Now, this is a formula that's also developed from the area formula for a rectangle. So to calculate our area here of our height, which is 20, and our base, which is 24, that goes the entire length of that side, we're simply going to take our 20 times our 24 and then divide that by 2. Now, that's a simplification of just simply saying 20 divided by 2, and then that's going to give me 10. 10 times that 24, that's going to give me 240. And our units now are centimeters squared. All right, and our next example is a parallelogram. Now, a parallelogram also has the area formula of base times height, where our base is simply one of the sides of the parallelogram, and the height is the perpendicular distance between those two parallel bases. So to find our area of this parallelogram, we're simply going to take our base 8 and our height 6 and multiply them together. 8 times 6, you guys know, is 48, and that's 48 meters squared. All right, in our next example, we have a not so common polygon, the trapezoid. But again, this trapezoid area formula is based off the area of a rectangle. And it is simply found by taking the height of that trapezoid, which is the perpendicular distance between the two parallel bases, and multiplying that to the sum of those two bases and dividing it by 2. So our example here, we have a height of 18 and the two bases of 27 and 36. So we're going to take that 18, we're going to multiply it to the sum of 27 and 36, and then we're going to take that product and divide it in half. Now remember, this fraction bar here is a grouping symbol. I must do my product in my numerator first, after I've added my parentheses, and then divide by 2. So that's going to give me 18 times 63 divided by 2. Or in other words, 9 times 63, and that's going to give me the product of 500, or sorry, it's going to give me the result of 567, and now we're talking about millimeters. So that's millimeters squared. And somehow that turned into a circle. So let's try that again. Millimeters squared. And that's our area for that trapezoid. All right, next up is a rhombus and a kite. They share the same area formula, which again is based off of the area for a rectangle. And you can see that in our little animation on our website there. So we're going to take the diagonals that go all the way across our rhombus or our kite, and we're simply going to multiply them together and divide them in half. So you can see in our example here, we got a kite that's got one diagonal of 12 and the other diagonal of 5. So that 12 times 5 divided by 2 is going to give me 60 over 2, which results in 30. And now we're talking about kilometers squared, which again turned into some sort of oval. So we'll see if we can get that problem fixed there. There's kilometers squared. All right, let's take a look at a few examples for today. Now, in this unit, we're not just interested in calculating area, but we're also interested in finding missing dimensions. So those dimensions can be found by substituting all the information in that we know and then solving for that missing dimension or variable. In this case, we want to find the base of a parallelogram whose area is 15 inches squared. All right, so I know that the area here of this parallelogram is 15, and I also know the area formula for a parallelogram is base times the height, which I know is 5. So I'm simply going to solve for my base by dividing both sides by 5, and that gives me a base. Of 3 inches. All right, in example 2, we want to find the length of the other diagonal in a kite when we know the area is 72 yards squared. So I know my area formula for a kite is diagonal 1 times diagonal 2, all divided by 2. So let's take a look here. We got our one diagonal is 16, the other diagonal we don't know. So we're going to find that diagonal by substituting in everything we do know. We know the area is 72, and that should be equal to the dimensions diagonal 1. Let's erase that. Diagonal 1, which is 16 times diagonal 2 divided by 2. All right, so we're going to first of all take 16 and divide it by 2. That's going to give us 8. So 72 is equal to 8 times, let's try that again, 8 times our diagonal. Looks like our technology is getting a little wonky on us. So 72 divided by 8. Oh, let's just make that another circle. It's all right. We are not going to let our technology beat us here. We got 72 divided by 8, which you guys know is 9. So that other diagonal needs to be 9, and our units here are going to be in yards because we're just talking about a length of that diagonal, not the area this time. All right, our next example here, we are going to find the height of the trapezoid that has base 11 and 15, and we know its area is equal to 117. So we're going to let 117 be equal to the height, which is what we're trying to find, times the sum of our bases, which is 11 plus 15. And remember, we need to divide that entire thing by 2. All right, so let's handle our parentheses first. 11 plus 15 is going to give us 26. That's 117 is now equal to 26. Whoops, let's try that again. Gotta have some patience with our technology today. All right, so we got 26h all over 2. All right, so we're going to take 26 and now divide that in half, and that gives us 117 is equal to 13h. My final step now is to divide both sides by 13. And when I divide by 13, I'm going to end up with a height that's equal to 9. Oh, let's try that again. 9 meters. All right, guys. That's technology snafus all over the place here. Does not like my M's. Wants to turn them into circles. All right. Our next one is a little bit trickier. Now we're looking at expressions for the dimensions here. We want to find the base of a rectangle whose area is 2xy square miles. Then give the perimeter of the rectangle. Well, you can see in our diagram that y is one of the dimensions. So I know the area formula for a rectangle is base times height. All right, so I'm going to fill in all that I know. 2xy is equal to my base, which I don't know, times my height, which is y. All right, now to find my base, I'm going to divide both sides by y. Now check out, here's what happens when I take the expression, 2xy and I divide it by y. So when I have a y in the top and the bottom of my fraction, those guys both reduce to 1. In other words, they cancel each other out. So I have 2x is equal to my base. So I'm going to write that right here on my diagram. So I got a rectangle that's 2x by y miles long. Now I want to find the perimeter of that rectangle, which means I need to add up all my sides. So I got a 2x plus a y plus some circle here, which I didn't really write. I'm going to write it again as a y. And then that means I'm going to have 4x plus 2y, and that's going to be equal to my perimeter. All right, now this is all in miles, and it's not miles squared because I'm talking about perimeter and not area. All right, for my final example for today here, I want to draw a triangle that has an altitude of 16x inches. If this triangle has an area of 36x squared inches, find the length of the base. So let's just sketch out a triangle here. And we're going to say that the altitude right here is 16x. So we'll write 16x here. And I know that the area of a triangle is base times height divided by 2. Pause the video now and try this example on your own and see if you can come up with the expression for the base of this triangle. Okay, did you guys get the height is equal to 4.5x and our units here are going to be in inches? If so, then you're tracking with what we got going.